Hello everyone, welcome back to the video series. In the last video, you should have set up your car project and imported all of the additional components. In this video, we're going to make the first of the components necessary for this assignment, which is the sidewall part. The sidewall is a laser cut component made out of 1/8 inch acrylic. The purpose of the part is to hold on the front and rear axle onto the chassis base. That is done using a friction fit between the tabs on the chassis, which fit into the holes on the sidewall. To start, go ahead and click New Design to open up a new window. And then with all our parts, we're going to start with a sketch. We're going to put the sketch on the top plane, and we're going to start with the center rectangle. To do that, hit Create, Rectangle, Center Rectangle. Left click once on the origin, drag out, click again to finish the rectangle. Then we're going to dimension it using the dimension tool to be 14.6 millimeters tall by 160 millimeters long. Zoom in a little bit there. Okay, now we're going to create the holes for the axles. These holes are going to be 5.4 millimeters in diameter, and that just gives a little bit of clearance because our axles are 5 millimeters in diameter. So 5.4 millimeters. And instead of putting that dimension on both of these circles, we're going to use what's known as the equal constraint. The equal constraint just basically makes sure that these two circles will always stay the same size. So click once on the dimensioned circle and then click again on the other one. And you can see this equal sign shows up. And now if I change this to be maybe 8 millimeters, both of them change. So we're going to change this back to 5.4 millimeters. And then we're going to draw another concentric circle around both of these parts. Okay. And we're going to put another equal constraint on these. There we go. And then we're going to dimension from the inner circle to the outer circle to be 5 millimeters. So that gives us a little bit of wall thickness there that we want. Now we need to connect these outer circles to our main rectangle. We're going to do that with some vertical lines. So use the line tool here. Zoom in a little bit and make sure you see this X. That X means that you're on the outer circle. And then drag up and make sure you see this little box here, and that means that it's at a right angle or that it's going to be perpendicular to the rectangle, which is what we want. So we want 2 of those. Doesn't matter where on the circle right now, we're going to fix that later. So you want 2 vertical lines like that. If you didn't happen to make them vertical, that's okay. Just need them to be connected, and you could add a vertical constraint here like that, and that'll fix it. So there's a horizontal vertical constraint. It takes whatever it's closest to and makes it either horizontal or vertical. So same thing here, one more line. And now we want to make these lines tangent to our circles. So we're going to do that with the tangent constraint, which is right here. So click once on the line and once on the circle that it needs to be tangent to. And there we go. Do that with all 4 of these lines. There we go. So the last thing, or second to last thing we need to do is get rid of some of these extra lines. So you can see here we don't have one clean profile. We've got kind of 5 different profiles that we don't need. To fix that, we're going to trim some of these lines. So using the little scissors tool here, which is known as trim. So you can remove that line and this line on both of these little cutouts. There we go. Okay, so now we just need to dimension where these circles are. So to do that, we're going to hit the dimension tool again, and we're going to dimension the center of this circle to be 13.825 millimeters down from the center of the rectangle. And then we're going to dimension the center of the circle from the left edge to be 14.5 millimeters. So So you can see now these lines are all black, which means that this one is fully constrained, but this one is not. The nice thing about our part is that it has symmetry. So in order to limit the number of dimensions we have and instead use that symmetry, we're going to go ahead and add a symmetric constraint. In order to add a symmetric constraint, we need a center line that we're going to use. So we're going to create that by creating a line and then hitting the construction button over here on the sketch palette. And that'll basically make a line that's dotted, kind of like this one over here. And that line cannot be used for geometries, it's just there for construction purposes. So you can see it's dotted like that. Make sure to hit the construction line again, or every other line or circle or rectangle you make after will also be construction. Now we want to make the center point here symmetric with this center point using this line as our center line. So hit the symmetry constraint, hit the center here, hit the center here, and hit our line. And you can see now it has a symmetric constraint and can no longer move. So that's our first sketch. So we can go ahead and finish. And like I said, this part is made out of laser cut material, and the laser cut material that we have in the labs is either acrylic or plywood. But either way, both of those materials are 1/8 inch in thickness, so that's what we need our part to be. So we're going to hit the extrude command, select our profile. You can actually, in this box here, you can type 0.125 inches, and it will automatically recognize that it's in inches, and you don't need to convert that to millimeters yourself. All right, now we need to make the 3 rectangles that are going to slot onto our chassis base. So we start by making one rectangle here in the center, another sketch on top of that face. Going to do another center rectangle at the origin here. And this one is going to be 24.4 millimeters by 6.6 millimeters. And the reasoning behind those dimensions are the MDF that we're using is 1/2 inch material. We want to have a nice tight fit between the laser cut and the MDF. So 6.6 leaves just a little bit of clearance that it's just still a nice tight friction fit. And the tabs are made to be 24 millimeters apart, or 24 millimeters in width. So the 0.4 millimeters just gives a little bit extra clearance because that dimension is going to be kind of handmade, unlike the 6.6, which is just from the thickness of the material. So it gives us a little bit more wiggle room when we're making the handmade part, essentially. All right, so we're going to finish the sketch now because all our lines are fully constrained. We're going to extrude again, but this time we want to cut this material away. So we select our profile, and instead of doing a distance, we're going to do a to object. So in this case, we're going to select the object where the extrude is going to end. And in this case, it's the bottom edge of this part, or bottom face. And you can see here this automatically changes the operation from a joining operation to a cut operation, which is what we want. You see it shows up kind of red like this. That means you're removing material, which is good. That's what we want. So we're going to go ahead and press OK. And now you can see we've cut out a little rectangle in the center. So now we need 3 more of those, or 2 more of those, sorry, spaced apart at a regular interval. So the best way to do that is with a rectangular pattern. So the pattern type that we're going to use is we don't want faces, we actually want to replicate that entire feature. So go ahead and press Features. And then from the timeline down here, you can select Extrude To. So then the next thing we need to know is the direction that we want. So the direction can be done by selecting an edge. You could select an axis as well. So you could select I think it's the x-axis here, but I just like to use the edge that's already on the part. And then we want to change from one direction to symmetric because we want to go on both sides of this starting line here. And the distance we want to use is one second here, it's 46 millimeters. So we can select the distance over here on the right to be 46 millimeters. You can see it is spaced apart correctly. So the way a rectangular pattern works is it actually patterns in two directions. So you can see here if I change the distance, it's actually patterning more than we need. So we're going to just change the quantity down here to 1. So that just removes any extra patterns in the second direction because we only want the pattern in the first direction. You can change the distance here as well to be 0, but it doesn't really matter at this point. Okay, so hit OK, and you should see the cutouts on both sides of the original cutout. And this is functionally our part is complete, but we're just going to add one more feature that just makes the part a little bit nicer to hold and look at, and that's going to be the Fillet Tool, also known as a roundover in other softwares. So to do that, hit the fillet, and then we're just going to select all the edges we want. So it's going to be these interior edges here on both sides of the axle, and then the four corners of our original rectangle. And you can use this drag handle here, and we're going to do, actually we're going to change it to 3 millimeters. There we go. So this is our part complete, and there's just one more thing I want to do, and that is to add an appearance. For most parts this doesn't really matter, but I find when I'm working with larger assemblies like this car, it's really nice to have all the parts be different colors, and that just makes it easier to kind of look at and see which part is which, and it just makes the assembly a little bit easier to work with. So I'm just going to show you how to do that. I made the part blue before, so we'll do the same here. And to add an appearance, we're going to go into Modify and scroll down here to Appearance. So there's two kind of things that make an appearance. It's the material property that you're giving, and then the color. So what we could do is, since this part is going to be plastic, we could give it a realistic material, like a translucent plastic. But I find that just kind of looks weird when you're working with the normal assembly. What you want to use those type of appearances for is when you're doing like a realistic render. So I'm just going to give it take this steel satin material, which is fine for now, and I'm going to edit it and change it to be a nice blue. You can kind of move that scroll wheel around, just make a nice color, and there we go. Now it's a nice blue color that will stick out and will have a nice contrast to the other parts in the assembly. Okay, so that's the sidewall part complete. The last step is just to save it. So press save, and you want to locate it in your car project under the custom parts, and we're going to call it the sidewall. And there you go, sidewall version 1 is complete. And like I showed you before, anytime you made any changes, say you wanted to change the spacing here or change any of the clearances to any of the parts, you could save it and have a different version. And you can go into your data panel here, and you can select which version you want to use. Okay, thank you very much. I'll see you in the next video.